This section is not quite as easy as the last one. The last one was all definitions. It's all you needed. And I forgot to tell you one important thing in the last section. And I'm going to make up for it in this section. You ready? Congruent circles are circles that have the same radius. That was it. It's the only thing I forgot to tell you. Congruent circles are circles that have the same radius but are not the same circle. So, for example, if all of these circles had a radius of 5, then they would be congruent circles. See how simple that is? Okay, today we're going to talk about tangents. T-A-N-G-E-N-T. A tangent is a line or line segment that touches a circle at only one place or one point. And that point is called the point of tangency. So for example, if I were to draw a line here, it touches my circle right there. One point, no more. It is not a chord, it's not a secant. This line is not a secant because this line does not make a chord through there. It doesn't touch the circle twice, only touches it once. And that point is called the point of tangency. This is a theorem that states if a line is a tangent to a circle, like this one is, then the line is perpendicular to the radius at the point of tangency. So in other words, it doesn't matter where this tangent is. If the tangent was over here, I could draw a radius from here to the line, and that would form a perfect right triangle. No, sorry, that would form a perfect right angle. Okay. Okay, we're back. I had an issue. I think it's taken care of now. All right. If a line is tangent to, we did all that. Point of tangency at right angle, whole 9 yards. Back over here. When there is a common point that has 2 tangents coming from it to the same circle, so there's my point. I get a tangent on this side, touching it here, and tangent on, whoops, that's not, working on it. And a tangent on this side, touching it here, pretending it's a tangent. Then this tangent has to be congruent to that tangent. And if I were to draw a line from here to the center of the circle, it actually bisects this angle. So those 2 angles would have to be congruent. And since we know that those 2 angles are congruent, and these 2 lines are congruent, and we know that this is a right angle, and that that is a right angle because of the last one there, then that means that this has to be congruent to that. And we know by the reflexive property that that is congruent to that, making these 2 congruent triangles. Now this mess only happens, and I took this and just ran with it, but this mess only happens when you have 2 tangents. Because if you don't have those 2 tangents, you don't get that these 2 are congruent, or that those 2 are congruent, or that we have the bisectors. But you could prove this by side, side, side. You could prove it by side, angle, side. You could prove it by hypotenuse, leg. Tons of ways you can prove those congruent triangles because they're all laid out right there for you. So you know that that's the case, which means you can find some other things. Now, the other thing you need to be concerned with is some definitions, because your book will use them on you and think that you should be a pro at them, when in reality, you're just now getting them. So you shouldn't be a pro at them yet. I'm getting ready to tell them to you. So you've got the whole tangent thing. You've got the point of tangency thing. Now let's talk about different kinds of pairs of tangents we can have. So the first kind we're going to talk about, if I can get this off, is internally tangent. Sorry, this isn't as easy as it looks. See, this is not simple. If I had a ruler, I'd do this next. These are internal tangent lines. They're called internal because they pass in between the two circles, and they are tangent to both the circles. We'll call this P, Q, and R. Then you have externally tangent lines. I can make it work. Meaning that they're tangent to both circles. Tangent to both circles, but they don't cross in between the two circles. They are on the outsides of the in between the two circles. Then we have internally tangent circles. We'll call that my outer circle. And then my inner circle would be like this, where they're only tangent at that one point. My outer circle can have a center here, my inner circle can have a center there, but they only touch at that one point. Those are internally tangent circles because one's inside of the other. If we have externally tangent circles, then you would have it like this, where they touch at one point on the outside. You know, one circle's on the outside of the other. In the internally tangent, one circle's inside the other. On the externally tangent, one circle's outside the other, but they're still only touching at that one point. Yeah, I do those with a form, but this over here, just freehand stuff. It happens. So those are the new definitions, the new rules, etc., etc. These are the classwork and homework I'm hoping you can do now based upon this. Not going to be easy for you now. It's going to make you think a little bit. So please make sure you either rewatch this or you write down the definitions and the postulates and theorems and stuff. And don't forget to go back and put them in your list, because you're going to want to be able to review them when it comes time for the final. Just saying. So on page 360, classwork. numbers 5, 8, and 12. And then the homework, that's not an 8. Homework is numbers 1, 3, 10, and 14. Hope that helps. See you in a couple days. Bye.